What is up, guys? Mr. B here, bringing another sweet, wicked, awesome math video. In this video, I'm going to take you through finding the inverse of a quadratic function, graphing the quadratic and the inverse, and then restricting the domain of the original quadratic so that the inverse is a function. That's a mouthful. All right, we don't have much time. Bam! Into the video. All right, so this is a bit of a, it's going to take a minor miracle to fit this in my 15-minute time limit, but you know what? We'll do it. We can do it. All right, so there's a lot of different methods in doing a, graph question like this, but I'm just going to follow the order that it's at. So the first thing I'm going to do is I'm going to determine the inverse of the quadratic. So when I'm finding the inverse algebraically, the very first thing that I do, and that you guys have to do as well, is to do the old switcheroo, switch x and y. All right, so where there was an x, now there's a y. All right, so if this thing is not in vertex form, it needs to be in vertex form. Luckily, a very smart, handsome man made this question up and put it in vertex form. So if it's not in vertex form, that's our first step. So now that we have the x and y's switched, the second step is to solve for y, okay? So whatever your k value happens to be, this thing floating out to the side, we got to get rid of that first. So I'll subtract that from both sides. So I get x minus 3 equals negative 1 over 2, y minus 1 squared. Then the next step I'm going to do is whatever this a value is, I got to get rid of it. So in order to get rid of that a value, I'm going to divide both sides by negative 1 over 2. You could choose to multiply both sides as well, but this is my preference. So those cancel. What we need to remember is we're not leaving a fraction in the denominator. So what we remember is that we're dividing by a fraction is the same as multiplying by the reciprocal. So if I'm dividing by negative 1 over 2, it's the same as multiplying by negative 2. So then I can write this as negative 2x minus 3. So remember that. Dividing by a fraction is exactly the same as multiplying by the reciprocal. Now I want to get y by itself. So the next thing I have to do is to get rid of the square root. And common error alert, this is the mistake that a lot of people will make, is that when you take the square root, you always have to remember plus or minus. Plus or minus, really, really easy to forget, but really, really important. All right, so if you forget the plus or minus, then you're losing half the solution, right? So keep that in mind, peeps. And then we end up with y minus 1. We want to get the y by itself, so the last step is just add 1 to both sides. So I get y equals 1 plus or minus the square root of negative 2x minus 3. So that's the algebraic part of this, and for the most part, that's pretty straightforward. It's the exact same process every time. Get vertex form if you don't have it, switch the x and the y's, and then solve for y, remembering plus or minus when we take the square root of both sides. Now, in graphing y and the inverse of y, so the quadratic that we're given, and then the inverse of that quadratic, we have to take sort of a systematic approach with that. There's a bunch of different ways of doing it. We're in a transformation unit, so why not rely on our powers of transformations, which is by the mapping rules. Now, there's other ways to do it that are absolutely quicker, no doubt about it. And if you want to do those, by all means, you can. And one of those ways is just choose the x values on either side of the vertex, right? You know the vertex, add 2 to both sides, use the axis of symmetry, yada, 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 you're done. I'm going to use the mapping rule. And so what I remember is that vertex form is ax minus h squared plus k. So when I go to write my mapping rule, so I'll write my mapping down here. I shouldn't use rule because people get mad at me when I use the word rule. It's not called the mapping rule. It's called the mapping, whatever. But anyway, not that I've been harmed by somebody because of that. But anyway, so remember, there's no b value in this, so we don't have to include the b in our mapping rule. So it's just x plus h for the first one. So it's x plus h. and ay plus k. So we have a is 1/2, negative 1/2. H is 1, and k is 3. So I can write that mapping, x plus 1, negative 1 over 2, y plus 3. So in order to actually transform something via the mapping rule, I need a base table. Every quadratic has the exact same base table, no matter how complicated the transformation. It's just the table for y is equal to x squared. So I can go ahead and choose negative 2, negative 1, 0, 1, 2. So my vertex being right in the middle at 0, 0. And then just go ahead and square each of them. You know, so 4, 1, 0, 1, 4. You guys probably have that ingrained in your head anyway at this point. And then we're going to transform that via the mapping rule. So I'm going to transform this by the mapping rule. So I'm going to take this table, run it through the mapping rule, and get a brand new, spanking new table. We might end up with decimals, but that's perfectly okay. So negative 2 plus 1, that's negative 2. Negative 1 plus 1, that's, negative 2 plus 1 is not negative 2, it is negative 1. Negative 1 plus 1 is 0, and then you see the pattern. 1, 2, and then 3. And then this one, we put the 4 in. 4 divided by negative 2 is negative 2, plus 3 is 1. And then 1 divided by negative 1/2, unfortunately, decimal, so it's going to be 0.5. Negative 0.5 plus 3, 2.5. No worries, be happy. And then 0 going in, that's going to give us 3. And then these things repeat, 2.5 and then 1. So you can check those for yourself if you're unsure about, oh, does mine repeat? They will, all right? So that is the y, right? So that's our transformation right there. That's that graph. So let's go ahead and graph it. So we'll go negative 1 and 1, so right there. 0 and 2.5, that is not right. Hang on now. 0 and 2.5 is up here. My bad. And then 1 and 3. And then 2 and 2.5. And then I got that one wrong too. Mental mistake. Mental mistake. All right. Let's go. Get it together. Negative 1 and 1 right here. I know you guys are yelling at the screen. Sir, you're an idiot. All right. So this is my inverse. Right, I'm not going to extend it too long because I don't want this graph to be, but they can keep going forever. So the thing about the inverse of a quadratic is that the inverse is not going to be a function. So you probably have heard about the horizontal line test. So if I draw a line through this function, then what happens is it touches 2 points. And if it touches 2 points, that means the inverse of it is not going to be a function. So in order to make sure that our inverse is a function, we have to restrict the domain of y. We have to choose one side or the other. So you notice here about the plus or the minus, that is really where the restriction comes in. So if we choose the right side of the parabola, which is this side right here, which is x is greater than or equal to negative 1. So if we say that x is greater than or equal to negative 1 for our restriction, that means we choose the plus of the inverse. If we choose the left side of the parabola, so x is less than or equal to 1, we choose the minus of the inverse. All right? So let's say, for example, we are going to choose the minus. No reason why. You have a choice. You can choose either one. So this is the minus sign right here. This is the minus side right here. So basically what we can do from that is we know that those are the points that we're going to include on our inverse. I'm going to graph the entire inverse first though, and then I'm going to show you how we get rid of them. But we could technically just get rid of those points right there. right? And these are these points right here, these first 2 points. And we could just use these 3 to graph our inverse, all right? So the next step would be to graph the inverse. So for the inverse, all you do is you switch x and y, all right? So you might write -1/2 y plus 3, and then x plus 1, and then switch those spots. So 1, 2.5, 3, 2.5, and 1, and then -1, 0, 1, 2, 3. So if I go ahead now, I'm going to plot this in red. So I'll go 1 and -1 right there. And then 2.5 and 0. And then 3 and 1. So we got some overlap. This thing gets a little messy, of course. And then 2.5 and 2. And then 3, or 1 and 3. So we do have a couple points in common. Something like that. All right. So we can only have half of that graph if we're going to restrict the domain. So we can't have both pieces. This fails the vertical line test, right? If I drew a vertical line test through this red graph, it touches 2 points. So I only want to keep half of it. So I decided that I'm choosing x is greater than -1 for y. All right, so that's this guy up here. That's what I'm going to, or less than or equal to. So that's the minus sign for my actual function. So then, remember, for x and y, all you're doing is you're switching, or for inverse, you're switching x and y. So this actually, this little restriction will become y is less than or equal to 1 for the actual, inverse, right? So everything has to be less than 1. So that is this line right across here, right? So this top part of the graph would not exist. And that's those 3 points that come from these values right here, right? Or those 2 points, right? Those are the 2 points that we eliminate when we choose x is less than 1. Those are the values of x is less than 1. So these are the values that we have on our actual graph. So that's how you restrict the function. Now, it doesn't specifically say to graph the restricted function, but I would assume that's what you should do, right? So all we would do is we would delete this top part of the function, and I'll just redraw that blue one in again. Make sure it's complete. And that would be our restricted function. Just the bottom half of that new graph. All right, so that's really important, and that's such a conceptual thing, right? That is such a conceptual thing to sort of sort out in your head. Now, I will label this as y and then y to the -1. Remember, exponent -1 in inverse, it means inverse, not reciprocal. Really easy to make that mistake. I know it also means reciprocal, but in this context where it says inverse, it means inverse, okay? So it's really, really important that you guys just straighten that in your own head. You need to come up with a method to remember that. So for me, I always start by choosing a plus or a minus. And knowing if I choose the plus, it's greater than or equal to, x is greater than or equal to the y coordinate of the vertex. If I choose less than, then I choose the minus, which means x is less than or equal to the minus. Now, you might want to write your function written out like that. I never did that, but you should certainly do that. So I should do it now. But I would also say to you that you need to remember how the domain and range works. They switch, right? What was my domain for the original now switches to my range. So once I decided that it was less than 1, now I know that my y values have to be less than 1, right? So my x was less than or equal to 1. Now my y values are less than or equal to 1 for my inverse. So that eliminates the part of the table that really does that. So these y values over here that are less than 1 get eliminated. Or sorry, that they keep, right? The ones that are greater than 1 get eliminated. All right? I said that confusingly. I wish I had more time to straighten it out, but I don't. Thanks for watching, guys. Like, share, subscribe.
A lot of boring math.
Get the fork out of here.